Hello, my name is Marcos Bernardo, and I'm doing a PhD in architecture at the Federal University of Minas Gerais in Brazil. I have been studying the intersection between cybernetic concepts and the concept of conviviality used by Ivan Illich. In this presentation, I will show part of this research, where I made adaptations to use the Tensegrity strategy in online meetings. In my research, I was trying to find better ways to organize for collective design processes, ways to overcome assemblies. Assemblies are spaces for unanimous decisions about subjects that are generic for all participants. But when designing your own neighborhood, that's not the case. There is a great variety of needs or desires. Matching the peculiar ways of living of multiple families is what can make a lively and diverse neighborhood. And studying beer, I found that for dealing with variety, a group needs to be capable of taking and integrating parallel decisions. This way, I started studying the meeting protocol of Tensegrity through available bibliography. Succinctly, in this protocol, 30 people meet in 12 groups of 5. Each person connects two groups, intertwining the whole. Each group discusses a different topic, suggested by the group itself, in a brainstorm dynamic called problem jostle. Additional connections are carried by critics who observe the meetings of the opposite groups. Two by two, the 12 groups meet in 6 rounds, and the whole process is repeated many times. To better understand the protocol, I made some programming to distribute topics and people into the icosahedron. The topics are displayed at the vertices and the participant names at the edges. Alternating rounds on the slider give us the two topics under discussion, their participants and critics. After understanding the protocol, I started searching for variations of it, for different group sizes, other than these existent ones. I was especially interested in variations that could include more people, 200 for example. So I created a polyhedron generator to obtain different sizes of groups when necessary. As I add vertices, it gives me the number of participants of the generated polyhedron. The topics are represented by numbers, and it gives me a list of the topics each row will discuss to connect the whole. From 6 to 60 topics without primes, 12 to 174 participants can be accommodated. These polyhedra are generated by a physics simulation, where vertices are the center of spheres tied together by elastics. The definition of rounds was made after. As I didn't obtain a formula to make this, I made it manually for each polyhedron. The hardest task is to define the critics, as some of these polyhedra are not symmetrical. This way, I found how many rounds are necessary for each meeting protocol, and which topics must be discussed each round. As the solid grows, more than 2 simultaneous meetings are allowed, keeping the protocol duration between bounds. But the role of critics becomes even more necessary to connect opposite groups. Meanwhile, these studies, the pandemic struck Brazil, and school classes, work meetings, parties all went online. The problem with online meetings is that most of them are assemblies, but with no channels for whispers. As Beer states, computers do not just happen to develop the trick of shouting to each other across the void, as human beings always do. So I thought a integration with no team would be a good way to improve our group interactions and test the protocol. So I called a group of 30 friends to meet in the shared canvas I prepared on the Miro platform. I reserved spaces with instructions for the problem jostle, the selection and voting of the 12 topics, and the selection of discussion roles by the participants themselves. For the problem jostle, I made a board for posting topics and 10 boxes around it with links to Go Talk video conference rooms. Rooms had a 4 people and 20 minutes limit for discussions. Names were dragged to the rooms to signal there was people inside, and the same for the topics being discussed. In the next section, people voted for topics to be further discussed by dragging them to an area and adding their names to them. Topics with more than 5 names were to be selected and dragged to another area, but not sufficient people engaged this step. So I selected the topics that had any vote and completed with the ones I remembered being discussed. The 12 meetings were realized in another interface called Spatial Chat, where people hear just who's near them. There were 2 meeting spaces, a schedule, a timer, and a reception with instructions. Interviewing participants after, I found that they were more interested in each other than in the topics, but still the topics were useful ways for better knowing each other. Being more confident in the application of the protocol, the next test was to use it in an online class of the architecture course. The four teachers wanted their 42 students to discuss the impacts of information technology in the manipulation of image. The interface they were using was Microsoft Teams, which permit to like the posts. So we did a simplified problem jostle. The statements were proposed, commented, and voted with likes. We grouped the similar statements and summed their votes. Then we selected to discuss the 16 top rated topics. Then the 42 students were distributed, each one connecting two from the topics they voted. The truncated tetrahedron was slightly distorted to make it easier to recognize opposing poles. 4 simultaneous meetings took place each round, each moderated by a teacher. In each round, participants changed groups and 4 different topics were discussed, totaling 16 meetings. In each group participated also 3 people from the opposite side. They watched and played the role of critics at the last 5 minutes of each meeting. They criticized both the form and the content of what was discussed, and also took what they saw to their groups, interconnecting distant discussions. Every round, 9 people were free to discuss between themselves or to observe any meeting. So every round we have participants, critics, observers, and moderators. The students argued fervently. No one was shy, as when everybody was together in Zoom. Some told they were at first worried about the complexity of the protocol, but it was actually very easy to follow. But for this smooth run, there was a hard work creating clear and short explanations and organizing rooms, schedules, and lists. It would be interesting if these tasks could be automated, as they follow strict logic and embedded in the conference software. In addition to the qualities already discussed in available articles, the protocol seems to enhance a quality Illich calls intersubjectivity. It seems a constructivist concept, as it states a situation where objects are consciously sustained by the interrelation of subjects. When focusing in verbal communication, the protocols favor this situation, leaving objects as contextual instruments for understanding. This way, information reverberates in the group by each person bringing their personal understanding from meeting to meeting. And more space for personal expression doesn't mean there is no space for the construction of shared concepts. Students quoted each other and contextualized ideas to different life stories, beginning to create a local entailment mesh of meanings. Many more can be discussed about the protocols and what can flourish from them. I'm very interested in discussing about it, especially as a way to open space inside the institutionalized practices to the interaction of local voices and desires.